And we are live. Hello, everyone, to today's Tech Excellence session. My name is Ollie, and as you already know by now, our vision is to raise the bar of technical excellence across the world. Who are we? Well, there's Valentina, who is our founder and organizer of Tech Excellence, and Daniel, Alina, and I are both co-organizers and co-hosts as well. We already had great sessions and speakers this year, and we will continue to have even more of them in the future. You can follow us on all the social media like Meetup, YouTube, LinkedIn, X, and GitHub, and also Discord, where you can also find other like-minded people and talk about software craftsmanship and related topics. Our sponsor is Optivem, and our partner is QE Unit. And today, I am very happy to be joined by Marcelo Chiaradia. Marcelo is a software engineer with nearly 20 years of experience. He is a naturalist and an advocate of software craftsmanship and XP practices like pair programming, CI/CD, TDD, refactoring, and simple design. He focuses on quality practices and helps teams deliver value to the customer through continuous delivery of quality software, where he is always striving for technical excellence. And today, he will show us how to use fakes for testing. So we are already very excited to learn more about that. But before I hand over the mic, I want to remind the audience that you are very much encouraged to write down any comment, observation, or question you have in the chat down below, and we will make room to discuss them at the end of Marcelo's session. But now I hand over the mic to Marcelo. The stage is yours.
All right. So thanks. Thanks a lot, Oliver, and thanks everyone for joining. So I'm gonna share my screen right now. Let's go for it. And yeah, I guess everyone can see it now. So, sorry, there it goes. There it goes. And there it goes. So, all right. So my name is Marcelo. Thanks, Oliver, for the nice introduction. And I'm here to talk today about using fakes for testing. So, I have a small agenda prepared for today. Now, we are going to talk a little bit about what the importance of quality and testing, pretty much, why we want to have good tests, some testing techniques like test doubles, different kind of test doubles, and why we want to use them. I will show some examples and some pros and cons that we can have. And then I'm gonna, I have prepared a demo and a live coding session, and at the end we can have, some moments of the Q&A. So without further ado, let's jump into it. So the question, why quality? Why we want quality? I think that in order to answer this question, we have to go up a little bit to understand first what's our job as software engineers. So what's pretty much our goal? So a common answer to this is that our job is just solving people's problems through software. We want to address their needs. We want to make their lives better. Software is supposed to make people's lives better. And I think that's a common answer, but I think it's an accurate one. It's a good and simple answer. Now, the question comes is, how do we actually find out what people's problems are, especially when they change over time? And the short answer to this, probably many should guess, is through user feedback. We try to find out what they actually need through feedback. Now, we usually get some idea of what they need. We implement something, we release it, we put it in the hands of the users, and we collect some feedback, and we find out how helpful it was what we did. Maybe it was okay, maybe not. And this process is what we actually call the feedback cycle. Now, a critical question here is how often should we get feedback? So a small story about that, about my early years in the industry. I remember when I was just starting as a software engineer in the industry, the most common approach on software development was waterfall. I don't know if everyone here heard of it, but anyway, here it goes. the work pretty much consisted on different stages or phases, and they were executed in a particular order. I remember we had the first stage for getting requirements, pretty much finding out what the problem we wanted to solve was, and this only phase was taking a lot of months. Then we were getting a phase for designing our system, another one for implementing, another one for testing, another one for integrating. That was a really big headache. And finally, at the end of the whole process that was taking a really long time, we were finally releasing something into the hands of the user and getting, for the first time in months, some real tangible feedback. This is pretty much the infamous Big Bang release that you hear everywhere. So if it sounds painful and stressful, it's because it was like this. Now, the real problem anyway was not that. The real problem was actually what was happening right after the release. Most of the time, given that our feedback cycle was months long, at the very end, when we were actually releasing something, we were finding out that many of the assumptions that we made during the whole process turned out to be either incorrect or were just outdated. So in during that time, the problem had changed from the one that we were originally trying to solve. So as you can imagine, there was a big mismatch between what the users needed right at the moment of releasing our stuff to what our application was actually doing. And trying to address this mismatch, trying to shorten it, as you can imagine, was expensive and required a lot of work. So in this sense, every release was always a really big bet. And we didn't know what was going to happen. And given the nature of this, I remember there was a lot of anxiety in the team, especially when the release day was coming close. So every single time we were thinking, okay, we're going to release and we know what's going to happen after that. Yeah, it was not pretty. And another thing that I remember a lot was that we were quite not welcoming changes at all. We were actually afraid of changes, especially the ones that were coming in the middle of the process, because now from the perspective that I'm in right now, it's totally understandable. Every change that was coming right in the middle or meant that we had to do a lot of rework, things that we were supposedly done. Yeah, we had to do it again. So it was a really painful process. And the funny thing is that even when we were afraid of changes, every single time, always, there were changes coming in between. And yes, they require a lot of work. Yeah, I can tell by experience that this is not a nice place to be. Now, the thing about change, if there's something that is constant in our industry, it is change. This is just the way it is. Markets change, problems change, user needs change, and our software, whether we want it or not, needs to address this change. This is pretty much what is called software. It's meant to be soft. It's meant to be changed. So it's just the way it is, and it's just reality. I don't think there's any point of being afraid of changes because they're going to come anyway. It's just inevitable. So my take is that instead of fighting it or being afraid of it, what we need to do is try to find ways to sustainably react to change whenever it's necessary. And the key word here is sustainable. We don't want to depend on some heroic efforts whenever we need to change our software. Just consider that in software product that they span through decades, if every single change that we need to make or every release requires a lot of effort, it's crazy expensive and it's crazy risky to do. So yeah, it would be better if we optimize for making changes cheaply, safely, and fast. And in this sense, long feedback cycles, like in the case of waterfall, they don't help at all here. So this is what pretty much the agile movement tries to address, acknowledging that change is inevitable and embracing it instead of being afraid of it. How? By doing our best to accelerate feedback cycles, working in small increments and iterations. So instead of having big bang releases that we had in the past, we try to have small releases and just lowering the batch size, just releasing small things every time. So in this sense, we make small bets instead of big ones, So whenever we find out how wrong we were after the release, we can adapt cheaper and sooner because the mismatch between what the user actually needs and what our application does is quite smaller. So the fastest the feedback cycles, the smaller this mismatch is, and it's the cheapest to address it. So yeah, now there's a big catch here. In order to be able to work like this incrementally, our software pretty much our code base needs to go hand by hand with this. We need to be able to change with confidence our code base. We cannot fight our code base if we try to be agile, pretty much. It's just not possible to have fast feedback cycles if every time we have distraction because we have bugs and nothing works and nobody knows why. So yeah, we need a code base that is easy to change. Agility in this sense starts always at code level. So here is the answer to the question, why quality? This is pretty much why we want quality. Quality software is software that is easy to change. And at least from my perspective, I believe that they fairly pretty much says the same thing, but I think it's correct. Quality software is software that is easy to change. And in this sense, it's fundamental to have quality if we want to be able to release often and work small batches. So pretty much what we try to do is limiting the impact of change because change is going to come anyway. So we try to organize our code and follow some technical practices that help us doing that, lowering the cost every time we have to change. And yeah, I would argue that quality in this sense, if we want to do a good job as a software engineers, it's just not optional. And yeah, it's the way it is. Here I agree with what Ken Beck says. This is a quote from the Extreme Programming Playbook. Of the 4 project development variables, scope, cost, time, and quality isn't really a free variable. The only possible values are excellent and insanely excellent, depending on whether lives are at stake. I think he totally nails it. Quality, if you want to be able to release often and small batches, you need quality. The trick here in order to be working like this is to have, from my experience, working software the whole time. So if we have every time working software and we move from one working state to another working state, we can release software on demand. So change in this sense is not as expensive as we would expect. This is pretty much the concept of continuous delivery. We always have the software in a shippable state. We can just deploy on demand. So now, how do we know that our software is actually working? And here is where tests come actually to play. Testing is critical for any software product, I would say. The premise is pretty simple. Testing, they tell us with a certain threshold of confidence that our code does what we think it does. So this spans, it's pretty simple, but this spans some great side effects. The first one I can think of is refactoring. With this, we can refactor the code completely merciless and with a lot of confidence, making it every day a little bit better. So in this sense, we improve the quality of our code daily, and then it's easier to build upon it. So in this sense, tests remove fear of change. Another side effect is we can introduce changes or introduce changes, new behavior, whatever, and make sure that it works and make sure that everything else that we had before still works. Tests help us to avoid errors. Most of the errors that they reach production, usually they involve spending a lot of money and time. So the earliest we can catch the errors is the cheapest for us. In this case, testing is help us to prevent errors before they get to the user. They also provide a living documentation. So if you want to see what the system does, okay, go and check the test. In this sense, they also help if we want to onboard someone into the team. yeah, it's way easier if you have tests because you can just showing how the system works. Just go and check the test. And ultimately, they help us accelerate build cycles. So having fast build cycles allowing you to release and deploy often, lowering the batch size, lowering the risk, making and moving small steps is pretty much what at the end we want, just to get feedback from the user sooner. So in short, tests are enablers. They give us confidence and enable us to deliver continuously and sustainably over time. Now, there's a catch, as always. Tests are great, they sound really good, and so on. But in order to be able to work like this, we need good tests. And yeah, what do good tests look like? Well, good tests usually they are described in a certain set of properties that we have. Actually, they are not coming from me. They are mostly coming from Ken Beck as well. So these are the properties that we would like tests to have. We want them to be fast. We want them to run them often. So yeah, the faster they are, the more we're gonna run them. We want them to be cheap to write. The same. The faster they are to write, and yeah, the more tests we're gonna write, and the more motivated we're gonna be to do it. We want to be readable. So whenever you see a test, it should be almost instant, easy to understand. We want them to be isolated. This means that we want them to repeat them, and every time that we run them, we want the same result. We want them to be inspiring. Yeah, this means that whenever a test passes, it should give us some confidence on it. Yeah, and we want them to be behavioral. This means that this should be coupled to behavioral code and decoupled from the structural code. So whenever we perform some changes on the behaviors, this should fail, and that's a good thing. But whenever we perform some change in the structure of the code, actually the test should still pass. This is pretty much the definition of refactoring, not changing the behavior, but improving the design. And we want them to be deterministic. So every time they run, we want the same result. This means that they are not flaky, for example. And we want them to be written in a timely manner, ideally before the code. So we can actually see them fail, and they fail for the right reason. Yeah, so now, how do we write good tests? That's a big question. Ideally, they should match most of these properties that we have here, especially fast. We want fast feedback cycles. Now, we mentioned that good tests are also inspiring, and this means that they should give us confidence that when they pass, we can release. And nothing gives us way more confidence than actually using real implementations. Yeah, and pretty much because using real implementation, they match the conditions of our code on how it's going to be used in production. Now, there are some trade-offs. Ideally, we would like to use real implementations every time, but given the nature of software and given the nature of tools that we use, like databases, external web services, or some complex modules, we don't always can use real implementations because they are usually slow, they are non-deterministic, maybe they are not even there yet. Some of them, they might be expensive, some APIs. And so, yeah, there is a trade-off to be made here. So we would like to, whenever possible, use real implementations. Now, whenever possible means that they should be fast, they should be deterministic, they should be simple enough, and they should be available. They should be there. Yeah. So maybe you would ask, okay, what do we do when the real implementation is not like this and we cannot use it? That's why we use test doubles. Test doubles pretty much, they replace production objects for testing purposes. I think pretty much every software engineer heard of them. And they let us test our code without the drawbacks of using real implementations that are non-deterministic and so on. They give us more control in our tests. Now, test tables, we have different categories, and yeah, the first category is dummies. Dummies are just objects that actually they are not used at all. They are mostly just to fill parameters. For example, the null value in Java is just a dummy that you just pass in test. We have stubs that you pretty much pre-can some values that whenever a function is calling the test, yeah, we're gonna use that pre-can value for the test execution. We have a spice. They're pretty much like stubs, but they have some recording inner mechanism where you can actually spy on it and yeah, just make some decisions on it. We have mocks. Mocks are also like spies, but they are pre-programmed with some hard-coded expectations. They usually fail if those expectations are not met. Like they let you, for example, check if a function was called with some certain parameters and how many times and in which order and so on. And finally, we have fakes. Fakes are yeah, they are actually real implementations, but they are way lightweight. And an example is, for example, yeah, an in-memory database. Sometimes you don't want to use the database because it's expensive, it's slow, it's hard to set up. So you could have just an in-memory database with an inner map, for example. That would be a fake. Now, what I have seen so far in the wild is that most of the industry uses these three kind of test tables: stubs, mocks, and fakes. And stub and mocks, they always, or at least most of the time, 99% of the time, they are being used with mocking tools. So let's see an example, just to get the idea a little bit better. Let's suppose that we have a use case that is withdraw from some bank account. Now, our use case would do something like this. We would have to get a bank account from some persistent mechanism. We would have to check the balance to see if we can perform a withdrawal. We would perform the withdrawal, and finally, we would save the bank account again into the persistent mechanism. So a possible implementation to this would be just having an API and putting everything in just one class in the withdraw from bank account use case, the persistence, everything. This would make it a little bit hard to change, I would say, and whenever we need to perform something. So a better design would be to use collaborators for the tasks that we need to perform. For example, we could use a MySQL repository to handle the persistence and the bank account just to handle the check of the balance and perform the withdrawal, actually. Now, a better design, going a little bit further, we could actually have an interface instead of the real repository and make our real repository implement that interface. In this sense, we invert the relationship. This is just an example of the dependency inversion principle. It's the being solid and the interface segregation principle, which is the ein solid. We pretty much create a tailored interface to give us way more control, and we push away all the impure stuff, let's call it, like the MySQL repository is going away. So how do we test this? This is whether we have this design. How do we test it? So we are going to treat our whole use case as a behavioral unit, and we're going to try to test everything through the public interface. So ideally, as we said, we would like to use real implementations, but the MySQL bank account repository, we can imagine that under the hood uses a real database. So it would be expensive, slow, and so on, just to really use it. So what we do is we use a test table here. And then we add a test for the MySQL account repository. So let's see an example of how it would look like in the test. Having our implementation like this, our interface would actually look something like this. We would have, this is Java code. We would have a bank account repository, which pretty much two methods: getting an account by ID and saving an account. And this is how a test using mocks and stuff would look like. We have a test that should succeed when we have enough money in the bank account. Perform a withdrawal. You can see, for example, what we do. We first have a bank account, then we create a mock of the bank account repository using the Mockito library. Then we perform some assumption. We hard code some values saying that whenever we call the account by ID method in the bank account repository with exactly the parameters of the bank account ID, we should return that bank account. Then we create our use case, injecting the bank account repository. We perform the withdrawal. And finally, we verify in the mock that the method save was called only one time exactly with a bank account object that has that ID and it has €0. So you can see that here it's a little bit, it's not super expressive, the test. It's a little bit hard to understand what is actually going on and what we are actually testing. I would argue that in order to fully understand this, you would have to understand actually the production code, how the code is implemented, because here we have a lot of implementation detail. We are assuming, for example, that our use case is under the hood calling the account by ID method, and is under the hood actually also calling the same method with some particular parameters in some particular order. This is pretty much going against us regarding the documentation rule. We would like to read our test and know what our code is doing, not the other way around. So yeah, I think in this sense, mocks are not great. Another downside that they have is that most of the time it's easy to break invariance with mocks. We can make some hard-coded assumptions here that maybe they might not be true at all. For example, we don't really know how the account by ID method in the repository actually is behaving, but we are anyway here performing some hard-coded assumption of how we think it behaves. And even if the real repository behaves completely different, our test is going to pass. And then when we deploy to production, everything's going to blow up. So we would like to avoid that. Now, let's see how we would do this with fakes. With fakes, we would have in our design the same interface, and the implementation, you can see that it shows a fake bank account repository, implements the interface, and under the hood uses an error map. This is an in-memory map. So a test with fake would pretty much look like this. We have a bank account, we have a fake repository, and we instantiate it with the bank account. We have the withdraw use case, and we inject the repository on it. We perform a withdraw. We get the bank account from the repository, and we check that the balance is updated. So you can see here already. Let's compare. You can see that it's way shorter already, and it tells the story way easier. It contains way less implementation details. And in my opinion, it's way easier to refactor because it doesn't couple the code that much. I can read the code, the test code here, and can get an impression of what the code actually is doing without going to have and actually look at the code. So again, there's a catch. Ideally, the fake should behave as close as possible to the real implementation of the repository. If the fake doesn't, if they don't behave the same, maybe we can use this test. And if the fake actually does something that is completely divergent from the real behavior, this test is gonna still pass, and we are never gonna find out at all. So this is what is called the divergence problem, pretty much. Now, how can we address this? There is an artifact that we can use that is pretty much called contract test, that is used to make sure that our real implementation and our fake behave as close as possible. So in the contract test, we will have our repository. We will have a repository test that is targeting the repository. Then in the repository, we have the implementation of MySQL, and we have the fake implementation, and then we will have a test on the MySQL repository test and a test for the fake. Yes, we will have a test for the fake, and the MySQL would target the MySQL repository, and the fake test would target the fake. And in this sense, both implementation would have to pass the test for the same interface, and they would tell us roughly if both things works similarly. Now, something worth to mention, and it's something I've seen a lot. Whenever we are trying to test the behavior of our application, again, ideally we would like to use this, but something I've seen a lot is that people focus just too much in isolating, and they think that we should test the withdraw from bank account use case completely isolated. So what they do, they change this to use a test double, which would be kind of okay because it's a database and we don't want to use a real implementation, but then they go ahead and they also change the bank account to use a test double. And they create a bank account test specifically for this. And yeah, this pretty much matches the test code to the implementation code. We have almost one-on-one. And the problem that this creates is that whenever let's suppose that we want to move some behavior from the bank account back to the withdraw use case, we would instantly have a failing test there, and we would instantly have a failing test there. So, and the same would happen if we, for example, we want to remove fully the bank account class and just merge it together with the withdraw use case. And this is actually the problem that this happens is that whenever you are refactoring and doing some changes like this in production code, you don't want your test to fail because you actually didn't change any behavior at all. It's just a structure, and this is getting into in the way for you to refactor. So yeah, whenever you can, prefer real implementations. Like we did before, instead of a bank account fake, we would use a bank account real. So let's all see this working. Now, I have prepared a small code base for it. Here it is. Yeah, this is Java code. I hope that the text is not small enough. Here we have implemented the use case. Let me just change to the branch. So you can see here that we have our application, we have our withdraw use case. Our withdraw use case pretty much gets a bank account from the repository, then we perform a withdraw in the bank account, and then we save the bank account back into the repository. We have tests for this, and we have the test fully for the use case. You can see that our use case here is, in the test, we are actually using mocks, and we use a mock for the bank account. We use a mock for the repository. The withdraw use case is actually a real implementation, and then we perform a lot of verifying and hard-coded assumptions. So pretty much what we are doing here is fully isolating the withdraw use case and using mocks for all the other collaborators. This is pretty much what we were showing. Okay, my screen just went away. Apparently. Sorry, I need to find my screen again, my presentation. So it just went away. All right, here we are. So sorry for that. This case is what we were showing right here, where we isolate fully the use case and we have a one-to-one. So let's go back. Now let's try to, for example, make a small change in our bank account. We saw that our use case, for example, relies in this collaborator in the bank account. All the tests, let's run them and let's see them passing. So there they are. They are all using mocks. Now let's try to perform some small refactoring. Let's suppose that we want our bank account to be an immutable object. So our withdraw, instead of updating the balance internally, it's just gonna return a new bank account, and here we will pass the ID, and here we will pass the updated balance. This is failing because I forgot the new. And then we will have to update our use case. So this would be after withdraw, and we would save the withdraw. So let's run all the tests again. And you see that we actually didn't change any behavior at all, but we already have this failing test. And yeah, whenever you want to refactor something like this without changing behavior, if this happens, it's extremely annoying, and you're gonna start hating your test, and they're gonna get in the way instead of helping you. So this is what I would try to avoid, not having a one-to-one relationship with your code. So let's reset our code, and let's see what would happen with mocks. There it goes. So we have with mocks, we pretty much have the same implementation, but you can see that our test is still using mocks for the repository, but for the bank account, it shows using the real implementation. It doesn't use a mock like we had before. Let's run all our tests. Yeah, they run pretty good. Now let's try to make the same refactoring. Let's make our bank account withdraw method return some immutable object. Let's pass here the ID, and let's pass the new balance, and we are gonna comment out this part, and then we are gonna update the use case. So this is after withdraw. Let's see what happens. And everything passes again because our test is actually here using a real bank account. Now, we are still using mocks here, so we are performing an assumption that our code under the hood is gonna call a save method with these particular values. Let's perform a small experiment. We have in the interface, apart from the same method, we have a tiny method that is for updating the balance. That is pretty much doing exactly this. Actually, we have this for the real implementation like this, and they are all running. I need a Docker container for running that. So there it is. It's up for connections. And let's show that we have a test for the real ShapePA implementation of the repository, which is this one. We here have implemented the get account by ID, the save, and update the balance. And our test pretty much runs this against a real PostgreSQL database. So all the tests pass. So let's suppose that in our use case, instead of the same method, we would like to change the interface and use this update balance. So here we would have to pass the ID, and here we would have to pass the balance, and then we don't want this anymore. Just note that here I don't change any semantics at all. I only change the method that we call, but under the hood, these two methods, they do the same. So let's run the use case test. And you see that we have a failure here as well. And where we actually didn't change any behavior at all. This should just work, but we have a failing test, and whenever you want to refactor something and moving some behavior from one side to the other, or even changing the interfaces, the tests are failing, and you say, you know what, this refactoring thing doesn't work. Well, actually, it's because our tests and our mocks are getting into the way. So let's try, let's reset our branch. And now let's go to see how we would do this with fakes. So we have the same production implementation, but in the test, let's close all this. In the test, we are using real implementations. Actually, this is not the real one that we are using in production. It's a fake one for the repository, but it's a real object. It's not a mock. And you can see that, again, the test is way, way smaller. From my perspective, it's way more readable as well. Now, you can see, as we were showing today, that for the interface of the repository, we actually have two implementations. We have the real one, the one that we are going to use in production, and we have the fake one. And both of them, they are using, or they are passing this contract test. The contract test, you can see that it shows a test that defines how that interface should behave from the point of view of the use case, and it's just an abstract method. And you can see that it's defined, the whole test is defined targeting the interface, which, this is actually the interface. And as you can imagine, we have two implementations of this test. One for the fake, that pretty much extends this one and just runs the whole test, but with the fake implementation. And we have one implementation from the real deal containing a lot of magic from Spring, but this under the hood actually uses the real Docker container that we have running with the real repository implementation that we would use in production. So again, let's run the real implementation to show that it works. And let's run the fake test to show that it works. And we can actually run all the tests. So one thing to notice instantly is that running tests with fakes and with real implementation, it really is way, way more faster. Let's take a look again to how we do it in mocks. Let's run all the tests. It takes way longer. I mean, here the application is really small, so you cannot, it's almost 600 milliseconds. That you're saying that's okay. But as the application grows and we have way more mocks, these times start to grow and grow and grow. And whenever you want to run the test, it takes more and more. So going back to the fakes, the difference is, it's hundreds of order of magnitudes. It's only 41 milliseconds running all the tests. Now, let's try, as we did today, let's try to perform the refactoring of having our bank account withdraw, returning an immutable object. So here we're gonna return a new bank account. We're gonna pass the ID. We are gonna pass the updated balance. I have a lot of parameters there. And we comment out this, and then we need to update our use case. So here is after withdraw. Now let's run all our tests. They pass. This is great. It's actually the same as the mocks before because we are using real implementation. Now let's try to do the same change as we did today. Let's use here the update balance method instead of the save. So here we pass the ID and we pass the balance, and everything works. We don't have a failing test in this case, as you can see, as we had in the previous scenario. Pretty much because we didn't change any behavior at all, and our test under the hood, this one here is actually using a real instance. So this fake implements every single method of the interface. So in this case, using fakes in a test or real object actually help us performing some refactorings. So this was all for the demo. Let's go back to our presentation. So by the way, every single thing that I show here is in this repository. This is in my GitHub account. So you can just take a look on the code base and play with it. Now, you could see that using fakes and using real instances, it helps us refactoring a lot, especially with, again, the test fragility problem. We don't want to change some behavior in our code, only behavior, or let's say, we don't want to change some structure in our code without changing behavior and having our test fail. That's just hindering us. So if you want to be able to refactor your code, your test shouldn't be fragile at all. In this sense, fakes help a lot. Something else that is worth noting, using fakes kind of forces you to have some abstractions, like, for example, our bank account repository. If you use mocking libraries, with mocking libraries, you can do pretty much whatever you want. You can put everything in the same class and even mocking a static method or even mocking the result set that comes from the database. You can do a lot of things. And in my opinion, they are not good things to do. People should be aware of the trade-off that they are doing. And even if the mocking library lets you do all this stuff, it doesn't mean that you should. So from my perspective, using fake in this sense, it promotes a great design because it forces you to create an abstraction. That's pretty much how it is. Now, another thing to note is that if you combine this approach using fakes, using real implementations when possible, and using contract testing, you can pretty much test your whole application without the need of, or almost without the need of end-to-end tests. My approach that I usually follow is this exactly thing, and then I add some smoke tests at the end. And I don't test the whole application from the API, all the business rules, and so on, using end-to-end tests. With mocks, usually this is not possible to do, given that we saw that, for example, with mocks, you can have this mismatch. If the mock behaves differently, maybe your test is never going to find out. So in order to find out these gaps, you actually need some end-to-end tests. There's no other way around, or you have to deploy and just live with it and knowing that maybe your application is going to fail even when supposedly all the tests are passing. So in this sense, I believe that using fakes is way more effective. Now, some drawbacks that I hear sometimes when I try to introduce this in teams, they come and say, hey, you know what? Our interfaces are too big, the one that we have right now, so we cannot use fakes, and or implemented fakes would take forever. Well, that is true. My question is usually, are you sure that it's okay that your interfaces are too big? Are you sure you want to make that trade-off? Maybe your interface is just doing too much things. So in my opinion, implementing a fake shouldn't be hard at all. You should try to keep your interfaces small. Another thing that I hear a lot, you know what, we have a lot of stuff in our database, so implementing a fake, it wouldn't be possible because we have a lot of logic in the database. Well, my same question, is this some trade-off that you are actually, you want to do? You want to have some logic in the database? Maybe you do, maybe that's okay. But at least if you try to introduce fake, you're gonna be forced to think about it. Yeah. So another classic that I hear sometimes, you know what? I cannot make a fake for the HTTP request servlet or the result set because it have like 100,000 methods from the Java library, and it's just not possible. Well, this is pretty much coming to another principle, that is, don't mock what you don't own. And again, don't depend on things that you don't need. So having a fake here is going to force you to create an abstraction around this third-party library, whatever it is, and limit our interface, just pretty much tailoring your interface to whatever you actually need and leave all the other things behind. So again, in this sense, having fakes or trying to think about fakes is going to force you to at least think about if you would have better separation of concerns or it's just create some abstractions around your things. I think trying to go in the fake approach is gonna start pinpointing all these problems that at least gonna make you think a lot, especially when you are trying to introduce it in legacy code. All right, so coming back to the good properties test, we had fast. Now, let's compare with mocks and fake. For example, test. For example, fast. With mocks, okay, we saw that they are fast, but given that usually the libraries use reflection under the hood, they are not as fast as the using fakes. We saw that, for example, with mocks, it was taking like 600 milliseconds. With fake, it was taking like 40. So yes, using mocks is fast, but is slower than fakes, that's for sure. Now, using mocks is easy to write. Well, so it's not super complicated, but you have to know the libraries, the mocking tools. You pretty much need to know the production code that you're gonna write, or you're gonna have to write the test after the code, which maybe is something you want to do, maybe it's not. I would argue that writing tests with fakes is way easier and way more straightforward. About readable, I would say pretty much the same. Reading a test with a lot of mocking implementation details in the middle is way harder because pretty much it makes you think, okay, how the production code is actually implemented. With fakes, you can just read the story in the test. Now, they are isolated. Yeah, they're pretty much isolated, I would say. They are inspiring. Here, the same. We are not sure. Using mocks is possible to perform some hard-coded assumptions that are not true. So if that test passes, it doesn't really tell us that our code is working. So here's the trade-off to be made. I don't think that using mocks is so inspiring. I would say that using fakes with contract tests that make sure that our fake behaves as a real implementation is way more inspiring, and it gives us way more confidence that our code actually does what we think it does. So behavioral and structure insensitive. We saw that with mocks, whenever we change something, for example, the interface from the save method of the repository to the update balance, it broke instantly. So they are not structure insensitive, and they are not behavioral. And in that case, we just change the behavior. We should change the structure, and we kept the behavior and the test file anyway. So I would argue that with mocks, this is not a given. With fakes, yes, we saw that with fake, we just changed the structure and the test was passing. Deterministic, yeah, we could say so. We could say so. Every time we run the test, we get the same result. Untimely, this is depends on what you want. In my opinion, writing tests first using mocks is way harder because you already have to think yes or yes how your code is gonna really be implemented. With fakes, you can just fully abstract that and think a little bit more in a black box approach. So some takes away that I would like you to leave this presentation with pretty much is focus on quality. Try to understand why quality is important. We cannot work in increments if we are fighting our code all the time. If we have a code that whenever we want to make a change, either it's breaking or it takes forever. So try to understand why we as software engineer wants quality. We cannot address people needs, especially changing people needs, if we don't work in small batches, and we cannot work in small batches if we don't have quality. Now, write tests. this seems obvious, but I've been in many things that, we didn't write tests at that moment, I would say. So write tests. These are your best friends. They help you prevent more of the errors to reach production, and they give you instant feedback, like super fast feedback, if your code is working or not. In this case, writing tests is always proactive. And you don't have to wait until there's a bug in production to actually write the test. You can write the test before that. It's going to help you anyways. So test behaviors, not implementations. Don't fall into the trap of having a one-to-one matching between your test code and the product code, because we saw what happened today. Whenever you want to move some behavior from one side to the other, all your tests are going to break, and you are lose complete confidence on your test suite. And this is just not what you want, because then you cannot refactor, and your code base is going to get worse and worse every time. Just try to test behaviors and follow a black box approach as much as you can. I can guarantee you as well that you're going to end up having way less tests in this sense. So this is a good advice to follow, in my opinion. Use real dependencies whenever possible. This is pretty much what it is. It's going to give you the most confidence whenever you can use the real option that is going to be used in production. And if there's no real dependency that you can use the next best thing, that is just fakes. Fakes makes your test more maintainable. They work closer to the real implementations as any other thing, especially if you have contract tests, and they force you to think about abstractions. So in this sense, they help you to design your code a little bit better. And lastly, just remember that tests should be enabled. Whenever you find that you are trying to change your code and your unit tests are preventing you from refactoring because they break, you are going to probably have to revisit how you are designing your tests. The tests need to be designed as much as production code. Now, some useful resources that I would like to share. The software engineering at Google Book is really great. Many of the things that you saw today in this presentation, you can find it there. And I totally recommend to read it. There are a couple of blog posts from Ken Beck, this test desiderator. He also has a series of videos attached to the blog, and pretty much explaining every single one of the good testing properties that we saw today. Similar in that sense is the first blog from Tim Ottinger and Chet Langer. They describe the first properties, the fast, isolated, repeatable, and so on. Another book recommendation, Extreme Test Patterns from Chiaradia Mesaros. It's a really great book. It has a really great explanation about test doubles and some patterns that you can follow to have better designs in your test. And in that sense, the same blog post about test doubles from Martin Fowler is actually that blog post makes a mention to the Extreme Test Patterns book. So a little bit about me. I'm a staff software engineer working at Tax2. We are a company in Germany, and what we do is just automating shows. Actually, not shows. We automate tax filing across all Europe. It's actually a cool domain, and so far a really cool company. And you can find me in LinkedIn under that, my profile, and that's also access to my GitHub account. I have the repository that we use today. I have it uploaded there, so if you want to play around. And that's pretty much. Thanks a lot for your time, and I hope that it was helpful.
Thank you very much, Marcelo. It was a very interesting talk. Let's dive directly into the questions then. So in the beginning, you were talking about a bit about agility. So there's also this question here by Roy Mustang. Is there any project context where waterfall would be acceptable in software engineering? What's your opinion?
Um, Not to my experience, at least. Um, I haven't been in any project in the past where we use waterfall or where we didn't use waterfall that I would say, okay, you know what, this would be okay with waterfall. Um, Not my experience. I don't know if someone else has a different experience on it, but from my perspective, is you always get a way better return on investment if you follow an agile approach and work in smaller batches, because with pretty much the same money and the same time you can make many more releases instead of waiting to make a crazy big bang release, possible spending your whole money on it just to find out that, okay, you know what, we were wrong. So yeah, on that sense, I would say no, but I'm not sure.
It is a good question. I would like to distinguish here, I guess, some perspectives um, between continuous, the importance of continuous delivery. So, the whole point of continuous delivery is that we need to make sure that our software is shippable to production at any time. So, that's the part that actually necessitates quality, that the software is shippable at any time. Now, whether or not we ship the software every minute or every day or every few months or maybe even say every several months or a year is dependent on other concerns. So the only real criteria that I see personally as the most critical criteria is the continuous delivery. It is nice to also push to production frequently, though I see it as something on top. I think there are maybe small number of industries where releases are more regulated, possibly maybe in finance and medicine. This might be the case where we have to space out the releases, but we can still work. How shall I say? We can still apply the continuous delivery principles by releasing frequently to the staging environment.
I totally agree. Something that people usually forgot is that they say, hey, you know what, we don't have to make releases that often, so we don't care about continuous delivery. Continuous delivery is not about that. Continuous delivery is being able to release at on demand. So as we saw, change is constant, so we really need to be able to do it if we are expecting to last in the industry for a couple of years at least. It's not about how many times we're going to release or whatever. It's about being able to do
it. So we also have some comments on this. So Andre Vieira says in highly strict and regulation coupled projects, for example, could be. And the other thing is also from Roy Mustang again. So in France, some aviation industrials do use waterfall, I think. Well, maybe they use it, but we don't. I mean, no comment on that. I just want to add the little thing called Kinefin framework here, because I think it's quite good to classify what problem space you're in. And if you are in a problem space where you can actually plan everything from start to end, then a waterfall approach might be viable. But how many times do you actually have that in software engineering? But as soon as you, for example, have done something and you need to do it again, it becomes more plannable, and thus you don't need the agile approach of like very short feedback loops. The feedback cycles can get probably a little bit further apart, because especially in the beginning, everything is completely unclear. And probably the more you start developing, the more clear stuff becomes, and then you can actually also have a little longer cycles. But of course, you always want to have feedback. So I would never say waterfall is a good idea. Just what I think is not everything needs a highly experimental, complex problem solution like Agile promotes it. That's at least my experience, especially when you look at projects where it takes after years you get changes in, but the changes are usually quite small. You don't need to change that much anymore. The UI is already clear. Then you probably don't need the agile approach, in my opinion, to the how it is defined, basically. But
this was, I think, a good discussion that we had. And coming back to this, for example, aviation industrials, if they want to achieve quality, they need to practice continuous delivery. That one is like no grayscale area. Whether they choose to release every 6 months or a year, like in waterfall, I see that as a separate argument. So the only real requirement for quality is continuous delivery. So continuous delivery, wherever we apply, that's the essence. And yes, for me, sure, for aviation, yes, they could do releases once a year.
So Roy wants to clarify that. So he's also not a fan of waterfall either, just to have that on the record too. So let's go to the next question. We have quite a lot. I will just put this here. I thought it was just one word from Mortadi Bakali. He said fixture when you showed the fake and mock stop slide. So I just want you to maybe comment on what is a fixture in the context of these test doubles.
I'm not entirely sure. Let me just read the question because I'm not entirely sure what it means.
I remember it was the test doubles slide where you had those 5 bullet points and it was simply commented fixture. So it is now up to you, your free interpretation. Maybe you could even tell us what the word fixture means and whether or not it's related to.
Okay, I don't recall having the fixture word in the presentation, but regardless, a fixture in the test is pretty much something that you want to be able to control your test environment. Pretty much every test that you create should be a super tiny universe that tells a story. And fixtures in this case, they are control setups that they let you pretty much control your test. For example, some feature would be creating a new fake repository every time, or having some hard-coded bank account value that you create every time with the same values and so on. So they help you make your tests repeatable. They help you make your tests isolated from each other. So I'm not really sure if I answered your question. I think it was something related to something I mentioned, but I don't have a regulation of having mentioned features at all.
No, you didn't. It's great. I just thought you could comment on it because you have so much experience in where would you actually put it in this whole test double discussion, because it was just mentioned like that. But this was a great answer. Thanks a lot. So the next one is also more of a comment. So it was, wow, I saw something similar in the book, The Art of Unit Testing. Amazing though old. Found the source code and upgraded the framework. So
true. Great book, by the way. I think this one is the one from Roy Osherov. So yeah, absolutely recommended.
So Roy was very active. So the next question is from him. So isn't contract tests introducing too much adherence to code design?
I wouldn't say so. From my experience, or pretty much, this is what that you wouldn't use fakes at all, and we would use just a mock for the repository. You would still have to test that mock. The alternative that you would have is if you don't want to test, or sorry, not test that mock, you would have to still test the repository, the thing that the mock is mocking to. And the alternative, if you don't want to add this test, you would have to have a full end-to-end test that actually exercise all the business rules and goes directly to the real repository. I would argue that that's not something that you want to do, because once you start, you're going to just keep adding more and more and more, and eventually all your test is going to be end-to-end tests flaky, that they usually take more time, and whenever they fail, you will have no idea why it failed. And so you will still need to somehow practice some separation of concern in your test and create a test for your repository. The contract test, in this sense, is just going a tiny step further than that and creating the same test for the fake, but it's not adding anything else, pretty much. The other thing that what you usually use contract test in is in the functions of the system. You usually don't use contract test inside all your business rule component, so you use it just to isolate some dependencies that you actually want to use fake with. So I would argue that if you wouldn't have contract tests and you wouldn't even use fakes at all, you should still have to test these parts in isolation. So I don't think this hinders the design in this sense.
Mhm. Thanks a lot for that answer. So we also have another question here. So Andre Vieira again, in what kind of situations would you rely on mocking instead of fakes?
Whenever there's not the fake available, that's pretty much my short answer. It sounds funny, but it's not. I really mean it. I think instead of, let's suppose that you don't have a fake available because either it's too complicated or so on. Okay, use a mock and use a mocking tool if you may. I've done it also, and I do it daily as well. It's not the best option. It still gives you some kind of confidence that, okay, you are testing something, but you know that you might have some gaps. The thing that I found really valuable using mocking tools is usually when working with legacy code, where I cannot just jump right away and implement a fake because the integration with the database either is completely melted into the business rules, or because maybe there's actually an interface, but the interface has 100 methods. So in those cases, I actually use mocking tools.
Yeah, there's no other chance there. you need to take what you can. So Valentina asks, in addition to comparing mocks versus fakes, how would you compare stubs versus fakes?
I would say the same, pretty much. My same answer as before. Whenever possible, I would try to use fakes. I mean, you would have the same problem, especially if you would use stubs with mocking tools. You would still make hard-coded assumptions that maybe they are not true. So you would break invariants, or you would make it easier to break invariants. You would make it easier to have these passing tests that shouldn't pass. And on this sense, sometimes I think using stubs is unavoidable, especially for exceptional conditions, for example. Sometimes you cannot fully recreate some exception conditions with fakes. It's just the way it is. So in that sense, there's no other way to use an stub, in my opinion, right there. And but it's a trade-off. You know that if the stub might get just out of sync really easy, you cannot have contract tests in that sense.
Exactly. I think it's good how you compared it. So this helps to also bring further completeness to the discussion. And regarding the case of, let's say, exceptions, what's the kind of approach that you do? Would you have, let's say, a fake for regular cases and then you would have stubs for exceptions, or would you within the fake add some, I don't know, special flags or
I would
method which set it up?
I would have a stub, but implemented in a real object without using the mocking tool. It would be pretty much like the fake object that you saw, but you precare it with saying, hey, please fail. Whenever something happens, fail. So
Yes, handwritten stub instead of the stub with the mocking tools. Okay, so to summarize, essentially you would use fake to simulate, I guess, the regular positive behavior of that external thing, and then you would have stubs to do the exceptions. Thanks for that.
Most of the time. I mean, for the exception that I couldn't recreate with the fakes, yes. But for example, coming back to the example of the in-memory repository, some of those exceptions you can recreate it. You can recreate what would happen if you try to save something that has a duplicated key, for example.
Yeah.
When those exceptions, you can do it with a regular fake. But some other exceptions, okay, what would happen if, I don't know, an out of air or whatever? Yeah, there's no other way to do it with a pre-can exception.
Exactly.
I mean, I guess you could program it into the fake, but at some point you need to test the fake then if it works correctly. My question is a bit, if you start with TDD, and how would you get to the fake there? I mean, yeah.
This is interesting because this application, for example, I created fully with TDD. In my opinion, TDD leads you to this kind of design, and just alone. Or I don't know if it's gonna lead you to use the fake, but at least to the design of having a separate interface and pushing your third-party code away. And it's gonna lead you to that design, and then it's gonna probably be in you if you want to go a little bit further on some upfront design and thinking how the code is going to be implemented. So then if you do that, maybe you could use some mocking libraries to write the test first and just specify how the code is going to be implemented so you can write it down in the test. And from my perspective, if you write the test first, it's way easier to do it with a fake. It's just way easier.
Mm-hmm. I also have a follow-up question on there regarding the sequence. So suppose you're implementing that use case, the one for withdraw money from bank account, and naturally at some point you hit the point where you're forced to add the interface, and in order to make that test execute, you need a concrete implementation, which is either going to be it could maybe a fake, maybe it's going to be a stub, maybe it's going to be mock, etc. So okay, and let's say okay, we're choosing fakes at the moment, and you choose a fake. Now do you then create the class with the fake and implement the fake to make the use case test pass? Or do you stop with the use case implementation but say to yourself, I'm now creating a new fake class, and okay, it will have these and these methods because of the interface, and now I'm going to jump to the contract test, write my contract test expectations of these new methods, get it working, and then shift back to the use case test after that activity? Like, which way do you go?
I understand what you mean. What I usually do is, I think pretty much you do the same. I just write the test first. The test probably is not even compiling because there are some classes, the fake class that is not even existing. So I just write the test, I make it compile. And whenever I create the fake class, given that I'm going to use it in the test and I don't want my test to pass just for whatever reason, the first thing I do, every single method that is used in production from the fake, I just add a throwing exception right there. Like, hey, this is thrown and not implemented. And if you run the test of the use case in that point, it's gonna fail. It's gonna fail because the fake is gonna just throw an exception. It's gonna then force you to go and write some contract test, or if you don't want to use a contract test, just a regular test for the fake. But yeah, in that sense, write the test of the use case, write the fake, make it fail. You're gonna have to write the test. I usually TDD my fakes as well. So once you have that working, you can come back to the use case and just continue. That's usually the workflow I follow.
Nice. Thanks a lot. So let's go to the next question. So Roy is asking, it looks like not only did you rely on the inversion principle, but also done some clean architecture. Would you say introducing a dev to fake testing would be easier if they know clean architecture already?
It looks like no. Introducing a dev to fake testing. Okay, if I would I would say that probably yes. I would say it's not mandatory. You can still not use clean architecture at all and use fakes if you would like. Um, I think you could say about the clean architecture because my repository was somewhere else and I had my business rules in a component apart, but I could have everything together in just one component and use fakes anyway. Yeah,
I think
that's the right answer here.
I think this question might be about if your team decides to use clean architecture and you start with testing. Does everyone has to know how clean architecture works in order to write those tests?
Yeah, I don't think so. You could use fakes without it. For sure, if you follow a clean architecture approach, writing fakes is gonna be way more obvious because it's gonna be really, really obvious and highlighted when the sanctions of your systems are and when you should probably implement contact tests and when you should probably use fakes. But other than that, no.
Yeah, and let's give one example. Imagine we're doing a big ball of mud. Like all the code is in the REST API controller. There's none of those, use case classes, but we are communicating with a database or SAP. We just, for those parts, let's say, introduce interface, introduce fakes. So our architecture is not clean architecture; it's a big ball of mud, with the exception that for outgoing infrastructure, we've got interfaces and fakes.
Yeah.
Yeah, I think that as long as you know how the dependency inversion principle works from solid, I mean, that's like old. I mean, that's probably already enough, hopefully.
Yeah, coming back to your comments just now, I think having fakes is a clear example of two of the solid principles. You
Yeah.
need the dependency immersion principle, you need the interface segregation principle, you want to create some interface, and you need the least code substitution principle. You want your fake to be substitutable with the real thing that you're going to use in production. So, and if you want go a little bit more ahead, the open close principle as well, because you can keep creating different implementations of your interface right there.
And hopefully it's also single responsible, and then you have the whole solid. Great.
Now, I also want to add one more comment here. When I personally work with teams, I firstly, on legacy projects, I do firstly switch to at least hexagonal architecture as a minimum. So not clean, but hexagonal as the minimum. And then the team can see, the interfaces. We're still working with mocks. So hexagonal architecture plus mocks. Then after that, I switch hexagonal architecture with fakes. And then by that time, the team, it's easier for them to understand it.
So I actually had somebody in the team that when they switched to clean architecture, he showed exactly what you did with replace, and he was so happy with it. We're replacing the repository on one hand with the in-memory and the other hand with the real one, and run the same test, just the same test.
Yeah. I mean, you could see that in the test I show in the test for the use case, I had hard coded the instantiation of the fake, but you could actually instantiate the real implementation and have the Docker container, and it should run the same.
Yeah. So let's go to the next question. A part of the behavior. Oh, sorry, Jean Carlos Alarthon Ochoa. I hope I got his name right. A part of the behavior, sometimes we want to verify if something was saved. For example, I use an approach to add additional functions on the fake to verify if something was saved. Is there a better way?
You could do that. You could do some some backdoor method to your fake if you want to inspect something in particular. This would make it a little bit more like a spy, in my opinion, not a full fake. And in the case I showed, it was not necessary because I could just use the public interface of the fake through the interface. So I could just save that, or yeah. But yeah, for sure, you could do that.
Okay. He also has another question. So there is a big debate between Chicago versus London schools. Are there scenarios based on your experience where mock is the only way we can use to verify our code? Maybe a hybrid approach.
My preference by experience is going on the Chicago school. This is trying to have bigger components and test through the public interface as much as I can and use real implementations as much as I can. Now, it's related to what we were talking today about when to use mocks. I usually use a hybrid approach, especially because I'm working most of the time in legacy code. So in this case, mocking tools and mocks, they help me a lot. And yeah, whenever I can, I add some fakes. But yeah, I use some hybrid approach in this case.
Okay,
I have
great.
one point to add here regarding this. I also happen to use Chicago most of the style, and it fit me well for nearly all use cases. So one example is that withdraw bank account, and that happened to correspond to my experience in reality as well. The only exceptions where I needed to do more fine-grained testing, not at the use case but actually zoom in, is when there was a combinatorial explosion. For example, in a mathematical style application where we have a use case, the use case is called like calculate, for example, credit score, and credit score is calculated by multiplying 50 factors. So one could be location factor, age factor, employment factor, and each of those 50 factors has its own business logic with lots of if-else statements, etc. If we were to test all that together, it would be probably infeasible. And then in those ones, I would test each of the factors in isolation, and the use case, I would set it up that it may, for example, use mocks then of the factors. So that is one exception which I've found, but for me it was very rare to occur.
That is true. I pretty much share the same opinion, but you could still do the same using real implementations, from my perspective. I mean, if you, I don't know if you remember in my code base, for example, even when using fakes, I had a special test for the bank account class that was testing the equality, exactly because of this reason that Valentina mentioned, that if not, you would have just a combinatorial expression of test. So sometimes this is necessary. You have to understand that it's the trade-off. If I would like to remove my bank account class and merge it together with something else, okay, I would have some failing tests, but it's something I am willing to do, especially because it's small. But regardless, if you chose going in that direction, you can still use the real bank account class in the use case test as well. It's not that you have to use a mocking tool, yes or yes.
Great. So here's another question. So in some projects, we tend to use unit testing for our implementations, mocking and verifying just calls. Personally, I think this approach is just a waste of time. We are not verifying nothing. What do you think?
I tend to agree to a certain degree. I believe that sometimes mocking is just the lesser evil. You're gonna have to use it sometimes, especially with legacy code. Yeah. But many times, especially overusing mocking tools, you end up in this situation where you are actually testing that, like they fairly say, that the code that you wrote is the code that you wrote. You actually don't test any behavior at all. So it's easy to go in that direction with mogging tools. That is true.
Okay, great. So actually, I think we are out of questions, but before we wrap it up, I just also want to show you, by the way, amazing presentation. Thank you so much for this content. And also, thank you for a great presentation. And I have more, like I learned so much in this session, and great stuff. Awesome session. I think you really earned it. It was really a great session. And now, wait a second. Exactly. So if you want to learn how to deliver quality software faster, then keep following us on all the social media. And of course, again, Marcelo, thank you very much for this session, and see you all next time.
Thanks
Bye.
a lot.